Hi everyone, this is Dr. Pushpendra Kumar Shukla, ANRF National Postdoctoral Fellow at Department of Mechanical Engineering, IIT-BHU. Today I am delighted to present my research entitled AI-Assisted Hybrid Nano-Textured Evaporative Cooling and PCM System for Thermal Management of EV Batteries in Extreme Climate Condition. This research addresses one of the biggest challenge in India, electric vehicles revolution, keeping batteries safe, efficient, reliable under Indian diverse climatic conditions. So as we all know, India experiences one of the wildest temperature variation in the world. In region like Ladakh, temperature can fall below 5 degrees Celsius, whereas in a region like Rajasthan, where road temperature can exceed 50 degrees Celsius. At high temperature, batteries degrade rapidly and may even go for thermal runaway sometime, which create a serious fire hazard. At very low temperature, charging slow down and which decrease the overall performance up to 30 to 20 to 30% in EV batteries. Unfortunately, most of the battery cooling technologies are developed for European as well and American climate condition, not specifically for India extreme weather condition. This clearly highlights the need of India specific battery thermal management solution. So that is what this project is about. So about BTMS, so battery thermal management is it work like just like a thermostat in our home. Its job is to keep battery between like optimal temperature range where efficiency will be the best. A good BTMS is not only improve the battery performance but also increase the battery life by nearly 30 to 40% while significantly improving the system. As we all know, if we maintain the temperature within optimum range, the battery life is also increasing rapidly. The real challenge is developing system that performs equally well during the cold as well as the very hot summers in India. This is exactly the objective of this research is. In this slide, I illustrate how temperature directly affects battery performance. Below 15 degrees Celsius, lithium plating occurs, charging becomes slow and vehicle range decrease. Between 20 to 40 degrees Celsius, the battery performance is optimum. So we definitely want to maintain the temperature between 20 to 40 degrees Celsius. Above 45 degrees Celsius, degradation accelerate rapidly. Once temperature approaches 80 degrees Celsius, which is very dangerous, thermal runaway can occur, posing a serious safety risk. Therefore, maintaining battery within the safe operating window is absolutely essential, and that is making our objective of this particular project. Currently, three major battery cooling technologies are used. First is air cooling technology. As we all know, it's a simple and inexpensive but ineffective during India's hot summer, since atmospheric temperature is itself going above 50 degrees Celsius sometime. Second, liquid cooling, which offers excellent cooling performance but increased system complexity, weight, maintenance due to pump and coolant channel, etc. Third is phase change material or PCM cooling, which passively absorb excessive heat without consuming additional power. However, PCM alone cannot efficiently handle prolonged heating and or extreme cold. Therefore, each existing technology has strength as well as limitation. That's why, to overcome all these limitations, in this particular project, I proposed a hybrid battery thermal management system. The first innovation is nano texturing evaporative cooling on the surface, fabricated using some nano fiber coating or metallic nano fiber coating of the surface and project. And finally, I will also use some artificial intelligence using machine learning models such as artificial neural network, which will integrate with CFD simulation and predict the battery temperature in real condition. So instead of relying on single cooling technology, my stream combines nano texturing, dielectric evaporative cooling, PCM, and AI. So like combination of all those things. So like in next 2 years, let's see how much I will able to do. But these are the like initial objective of my. So the expected outcome of research are both scientific as well as practical. First, I aim to develop a working laboratory prototype validated under temperature range from 5 to 50 degrees Celsius. And second, I will develop a CFD based digital twin integrated with AI for real-time battery temperature prediction. Third, the project is expected to generate of course, couple of good results which can be patented and all those things. So overall, these are the like a few aims of my current research project. So this directly aligned with India's national priorities, as we all know, by Honorable Prime Minister Narendra Modi ji, he has aimed to become 30% electric vehicle preparation by 2030. A safer and more reliable battery system is essential for achieving that particular target. The proposed technology, along with the objective of Flame Second, the National Cooling Action Plan, and the vision of Atmanirbhar Bharat by developing an indigenous battery thermal management solution designed specifically for Indian climate. To conclude, battery thermal management is one of the key technology that will determine the future success of electric vehicles. My proposed hybrid system combined advanced materials, innovate cooling technologies, computational modeling, artificial intelligence, and which create a safer, smarter, and more efficient battery solution. I believe this research has strong potential for future technologies transfer to Indian EV manufacturers and can contribute meaningfully toward India's sustainable transportation goal. Thank you very much for your kind attention, and I will be happy to answer if you have any questions. So these are my contact details and I will be definitely happy to be connected with all of you for any future potential collaboration, and let's work together for this particular aim. So thank you IIT Mandi for providing this opportunity, and ANR for funding me. So thank you so much for listening me, and I will be happy to stay connected with all of you. Thank you.